The final Fourier transform theorem I want to talk about is known as Parsifal's theorem, and it's really relevant for physics because it has to do with energy. So the energy in a system tends to be proportional to the square of some time-dependent variable. So for example, the energy dissipated by a resistor when driven by voltage V is given by the integral of V squared on R. The absolute value signs here account for complex or negative signals, and you recognize this as the power dissipated by a resistor of value R. Integrating the power gives you the energy. Now things look like the square are really common in energy type calculations. So for example, the power dissipated by an oscillator is proportional to the square of the amplitude. The energy in motion is proportional to the square of velocity. So integrating these squares to find the energy is a really common thing to have to do. So in this example here with the resistance and the voltage, if the voltage is some finite signal, the energy will be finite. And Parsifal's theorem says that the integral of some function over time squared is equal to the integral of the Fourier transform squared integrated over omega. So if you want to find the energy in a system, you can integrate the energy up in real space or in Fourier space, and sometimes one integral may be easier than the other. And sometimes you may have access to a Fourier transform but not the original function, or vice versa.